Let's look at the climbing stairs question from Grind 75. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Example 1, we have two steps and we have an output of 2, and that's because we can either take one step and one step, or we can take two steps. We have two ways that we can reach the top. Example 2, we have an input of 3. The output is 3. We can take one step, one step, one step, or we can take one step and two steps, or two steps and one step. Constraints are going to be that the value or the number of steps is going to be between 1 and 45. All right, let's take a look at the diagram. This is a fun one. So climbing stairs is probably one of the first introductory dynamic programming questions that you're going to get. And there's a few ways that you can solve this in the code. You're typically going to hear about recursion and memoization or tabulation. I'm going to be using the recursion and the memoization. But for now, let's just look at the problem and see if we can understand what the pattern is with this question. So whenever we're looking at a question, and in the question, they're going to be asking for the minimum number of something, the maximum number of something, or how many different ways are there to do something, that potentially can be a hint that it's actually a dynamic programming question. And dynamic programming questions are such that in order to figure out in order to solve for a particular input, we actually have to solve the problem for another input, or sometimes in other cases, several other inputs. So with this example, right, we have the climbing stairs. So in order to get to one step, the only way we can do that, right, is by taking one step. But to get to two steps, right, we have two ways that we can get there. We can take one step and one step, or two steps. And then when we get to 3, right, there's 3 ways to get up there, right? We can take 2 steps and one step, one step, one step, one steps, or 2 steps and one steps. That's 3 ways. And then when we get to 4, if you actually count them out here, I'm not going to go through all the examples, but there's actually 5 different ways. So whenever you're looking at this, you've got to ask yourself, well, what's the pattern here? So if we look at this, we can actually identify that 1 and 2 are the base cases, right? But when we look at 3, what's the pattern? Well, it looks like if I were to just take the answer for the previous 2 inputs, right, 1 plus 2, that's going to give us 3. And if I were to look at the 4, well, if I just add up the 2 previous examples, right, the 3 and the 2, that's going to give us a 5. And that's exactly what the pattern is. So outside of the base cases of 1 and 2, so these are the base cases, in every other occurrence, the way that we are going to find out how many ways there are to climb to a specific step is going to be the specific input minus 1 plus the specific input, which is the number of stairs, minus 2. And that's going to give us the solution that we're looking for. All right, let's get into the code, the fun part. As mentioned, I'm going to be using the recursion and the memoization approach. However, tabulation is perfectly valid. So when first looking at this problem, I'm going to solve the base cases. So I'm going to say if n is equal to 1, return 1. Meaning, if we only have one step, there's only one way to get there, which is to take one step. If n is equal to 2, we're going to go ahead and return 2, right? We can take a single double step or 2 single steps. After that, we're going to return climb stairs, and we're going to say n minus 1 plus climb stairs of n minus 2. Now, if I were to run this with a relatively small input of 10, you will see that it actually gives you the right answer. However, you should know that the time and space complexity on this are pretty challenging. You might have heard of the formula branching factor to the power of depth. And whenever you examine that formula, it actually applies directly here. So on line 8, there's actually a branching factor of 2, and the power, or the depth rather, is going to be n. And that's going to be the time and space complexity, right? 2 to the power of n, and as well with the space complexity, we could have a 2 to the power of n situation from the recursive calls. Now, in order to fix this, we're going to apply something called memoization, which is a fancy word of saying instead of solving the same problems again, we're going to store those answers somewhere in a cache or some kind of set or dictionary, and we're going to, instead of repeating that work, we're just going to return something that's already been solved. So the way that we're going to do that is by creating a variable called, we're going to call it cache, and that's going to be equal to an integer dictionary. And we're going to set up some initial values here. We're going to have 1 to 1, meaning if I ask for how many ways are there to climb to the first step, the answer is going to be 1. And for 2 to 2, so if I have, if I'm trying to climb to the second, to n is equal to 2, there's only 2 ways to get there, right? 2 single steps or a double step. And now that we have this cache here, what I can do is actually remove this code here on line 8 and 9 and say, if let existing answer is equal to the cache of n, return my existing answer. Imagine an input of n is equal to 10. So what's going to happen now that we have a cache, whenever we call climb stairs, right, n is going to equal to 10. This will eventually get passed to the next recursive call, n is going to equal to 9. And this is going to go all the way down, and it's going to keep hitting this return climb stairs n is equal to 1 here. Eventually, it's going to get to n is equal to 2. And when it hits n is equal to 2, it's just going to return the existing answer because we've already solved that input. There's no need to solve that again. That's also a base case. And from here on the right, it's going to solve climb stairs n minus 2, and it's going to read the 1, right? And so whenever n is equal to 3, the two pieces of work that were performed here are just going to read straight from the dictionary. And then at some point, we're going to have the answer for n is equal to 3, which is a non-base case. So we're going to store our sub answer, and that's going to equal to climb stairs of n minus 1 plus climb stairs of n minus 2. And what we're going to do now is access our cache and say, for the value of n, here is our sub answer. And of course, we're going to return our sub answer. And if we were to run this, you'll see that it passes. And if I were to submit this, you'll see that it indeed does pass. And the time and space complexity for this are going to be O of n. And same with the space complexity, O of n, O of n. I hope this video helped you. Have a good one.